Welcome to third part of LLM API hacking. And in this video, we are going to see how injection attacks can occur in LLM, particularly OS command injection. We're gonna start with a little introduction about OS command injection, some code examples, and then we will hop on to the Figure lab and we will see how we can exploit it in LLM API. Oh, and before we start, I want you to check out the description where I'm also uploading walkthroughs of these labs on my website, so do check it out. Okay, what is OS command injection? It is a security vulnerability that occurs when attacker can execute arbitrary operating system commands on the server running an application. So this happens when the application passes unsafe user input directly to system shell, so it's not checking if that input is acceptable or not. Is it a command or just normal input? For example, have a look at this code. Let's say there is a web application that allows users to upload files and then view the content of those files. Now this is the vulnerable backend code. So here is the function view file, and this handles requests that are coming from the view file path. Now, file name contains the value of the file name parameter from the URL query string. Now the important thing here is os.bopen, which basically execute the command to read the file that was uploaded from the uploads directory. Now this os.bopen function is not a safe method to use because it takes user input directly and then execute it. So if the attacker input something like this, /rf/, and this command will delete all the files from the server. What is the secure alternative for this? Obviously, don't use that function mentioned above. Instead, use function like subprocess.run. Have a look at this secure code over here. You can see subprocess.run is executing the command, but how it handle the user input is different from how that os.bopen was handling it, because subprocess.run take user input as arguments into a list, and each part is treated as a separate argument that prevents malicious commands. Okay, now you have a little idea of how OS command injection occur. Now let's see how it can occur in LLMs. Well, OS command injection can occur in LLMs that accept user input without client-side or server-side validation and pass those input to functions or APIs that are insecure. Let's have a look at this lab to understand this better. This application has a live chat functionality that is using LLM to interact with users. So let's try asking some questions and see how this chat box replies to it. So the first thing we're gonna ask is what APIs the chat box has access to. And it says password reset, subscribe to newsletter, and product info. So there are 3 APIs. Password reset is obvious. It resets the password of a particular user, providing their username or email. And subscribe to newsletter, basically subscribe a user to their newsletter, providing their email address. So it's taking email address as argument. Now product info basically fetch the information about a product. And here we can see we have provided an email as well in the email client. So it has this particular subdomain, and every email related to this subdomain will be showed here. Okay, now let's interact with subscribe to newsletter API. So we're gonna say subscribe to newsletter with this particular email. Right now we are providing a legit email that exists, and it says that we have successfully subscribed to that newsletter. And if you refresh the page, we can see that we got the email. Okay, now let's go back. And this time we are going to subscribe to newsletter with that email that doesn't exist. So we're gonna change the subdomain to xyz.net, and in the response it says successfully subscribed, so it's not checking if the email is valid or not. Okay, weird response. Now let's try to see how would it reply to an email that has this legit domain but a different username that doesn't exist. But in the email client, we can see we still got the response because the subdomain was same and we have access to the subdomain. That's why we are able to see that. Now let's try to inject an OS command like who am I. So here goes the syntax. Now let's see how the LLM responds to it. Okay, let's go back to email client. And over here we can see the response says here Carlos. So it's executing the who am I command, and that's why we are seeing Carlos over here instead of normal username, because it is not sanitizing the input and directly executing the command. So we can execute any command here. In order to solve this lab, we have to delete a particular txt file. So let's do that. Whoami command works in Linux. It means it is using Linux in backend. So the directory would be home, Carlos, and there would be a txt file which is morale.txt. If you read the lab description, it says that we have to delete the morale.txt file. So now it says that we solved the lab, means the file was deleted successfully. Okay, now you know how we can exploit OS command injection in LLM, but what could have happened in the backend? So since there is no input validation, this LLM is taking input directly and passing it to a function in the backend. And this function takes that email as argument and sends the email to a function that executes a particular command to send the user the response. But that function is not secure. It's also executing commands directly in the OS shell. It could be using commands like os.system to execute the provided user input and give the response back in that email client. It is very similar to the example we saw in the start of the video of the normal OS command injection. It's basically the same. It's just that LLM is taking that user input and passing it. So the prevention would be same here as well, to use safer functions like subprocess.run, which take input as arguments. Have a look at this code. Also, if the user is providing an input that is not valid and doesn't follow the format of an email address, for example, we provided $sign and circular bracket. This is not the format of the email address, so LLM shouldn't be accepting that and it should reject it right away. So there should be a client-side validation as well and server-side validation where it is using safer functions. Okay, so that's it for this video. I hope you enjoyed watching it. Let me know your views in the comment section, like and subscribe, and I'll see you in the next one.